Hi guys, and welcome back. Today's lesson we're going to be talking about the surface area and lateral area of pyramids. Okay, so we're actually cutting this lesson this video into two parts. So we're not going to be talking about cones today. It will just be pyramids. So let's go ahead and get started. Now, a pyramid is a 3D figure that has one base, and then all of the edges of that base come up and meet at a vertex. So you're going to see a lot of common language between between prisms and pyramids. The base is still at the bottom, and it's still how you name your shape. So this figure over here is a square pyramid because the base is a square. If it was a rectangle, it'd be a rectangular pyramid. If it was a hexagon, it'd be a hexagonal pyramid. Okay? You still have your lateral faces, you still have your lateral edges, only now the lateral faces are all triangles instead of rectangles like they were with prisms. Base edges are still called base edges, all of those things. Here is the new vocab word of the day: slant height. Slant height is the height of the lateral face. And what it does is it comes from the vertex and is perpendicular to the base. So it comes down the side of the lateral face from the vertex and is perpendicular to the base. It also, in a regular pyramid, and we'll talk about what a regular pyramid is in a second, bisects the edge of the base. Now, slant height is unique, and this is what makes pyramids so special. So we have two types of pyramids, and then I'll come back to slant height because we need to understand our types of pyramids first. We have two types of pyramids. We have regular pyramids and we have irregular pyramids or non-regular pyramid. Regular pyramids have two rules. Number one, the rule is it has to have a regular polygon for its base. So squares, equilateral triangles, regular hexagons, regular pentagons, regular nonagons, octagons, all of those things. And then secondly, the altitude has to go to the center of the base. So that's something on the last slide I didn't talk about, but the altitude, or the 3D height of the figure, comes from the vertex and is perpendicular to the base. And in a regular pyramid, it's going to be perpendicular to the center of the base. In irregular pyramids or oblique pyramids, you're either going to have an irregular base, like a rectangle or a trapezoid, or the vertex is going to be perpendicular, but it's going to be off-center. Now, the reason why this is important is because in a regular pyramid, all of our lateral faces are congruent, and they are isosceles triangles. So because the base itself, all of those sides are regular, all of those sides are congruent, that makes the lateral faces going up all congruent, which is where you get these isosceles triangles, which is where and why the equation that we're about to learn is going to work. With non-regular pyramids, because you either have an irregular base or because the altitude is off-center, the lateral faces going up are no longer isosceles triangles, or they're no longer all congruent isosceles triangles. So this face right here that I'm highlighting in blue, this face could be a different size, and probably is, a different size than this green face. So for non-regular pyramids, you're going to have to go the long way and manually find the area of all of the sides and of the base, and you're going to have to do more work because the equation doesn't work for non-regular pyramids because the sides are not the same size. So keep that in mind. But regular pyramids you have a lot of fun with. And this is where pyramids get interesting. So as promised, let's go back to slant height. Slant height, the reason why the slant height is so special with regular pyramids is because all of the lateral faces are isosceles triangles. We have a lot of triangles. Let's go over them. So first off, the vertical height, let me use a highlighter here so you can see. Okay, the vertical height and the slant height, these sides with this side right here form a right triangle. Okay? That's the vertical height, aka the altitude, with the slant height, which is going down the lateral face. And this side down here, for those of you who have forgotten, is the apothem. The apothem is back. I don't know if you can see that. I'm going to write it somewhere else. Now, because we have the apothem, this opens up a lot more triangles to us. For instance, now we have the apothem, the radius, and half of the base. Okay, because we have a regular figure, and that makes this right here a right triangle. Because we have a regular figure, so the apothem, the radius of the base, and half of the base gives us that little small right triangle that we learned in last chapter. Then, because the slant height is the altitude of the isosceles triangle, let's talk about this triangle where you have the slant height, the lateral edge, and half the base, and that makes another right triangle. And then last but not least, it just keeps going. Last but not least, you have, hold on, let me get the color. You have the lateral edge, you have the radius, and then you have the 3D height, or the altitude, and guess what? That also makes its own right triangle. So, the reason why we like regular pyramids is because there are a lot of right triangles going on and a lot of these pieces that could happen. So, one of the biggest curveballs that a pyramid is going to throw at you is by giving you one of these pieces, and then you either have to use trig, special right triangles, or Pythagorean theorem to find the other pieces. So, it might be helpful for you to have this picture in your notes and to acknowledge or to draw somehow all of these right triangles so you can make sure you know what they're doing. So now that we know all the pieces, let's talk about the equation. Now when you have pyramids, again, remember this only works for regular pyramids because the base sides have to be the same. The lateral area is going to be the perimeter of the base times the slant height divided by 2. Or you can use this equation. Same equation, just slightly different formats. Now, slant height will always be that cursive L. Slant height is also sometimes known as lateral height because it's the height of the lateral face. Just kind of keep that in mind. Here we go. Now, in this problem, we have the lateral area of a regular hexagonal pyramid with a base edge of 9 centimeters and a lateral height of 7 centimeters. Now, you don't need to draw the picture, but you should draw the picture. That way, there's a lot going on in these pictures, and if you draw the picture, it kind of helps you orient yourself on what's going on. Now, how do you draw pyramids? Well, you draw your base about as flat as you can, and then you draw your vertex. And then you hope that everything's going to work out nicely. And that's about the best you can do. So, there is my pyramid, my regular hexagonal pyramid, and now I'm going to write in all of my pieces. So my base edge is 9 centimeters, so that means this edge right here is 9. And then my lateral height, so it's going to come from the vertex, and it's going to go down the side and be perpendicular to the base. My lateral height, or my slant height, is 7 centimeters. So this problem is nice to us. It actually gives us a lot of information. So here we go. Lateral area is equal to the perimeter of the base times the slant height divided by 2. So I need my perimeter and I need my slant height. My slant height is given to me, that's 7. My perimeter is going to be 9 times the number of sides, so 6, and therefore it's going to be 54. So So now I can take these numbers and plug them back into my equation. So I have 54 times 7 divided by 2. And this is going to give me 189 centimeters squared. Remember, we're dealing with area, so our units are squared units. And that's basically it. Now, like I said, this problem is nice to us because it gives us a lot of the pieces. As I said earlier, one of the easiest ways these problems are going to level up is by making us find the pieces. Before we get to those problems, though, let's add our next equation, surface area. Surface area is when you take the lateral area and you add the area of the singular base. So, just like prisms, where we had the lateral area, which is the area of all of the lateral faces, now all we're doing is adding the base. And because there's only one base in a pyramid, we only have to add one number. So surface area, or total area as it's sometimes called, is the lateral area plus the area of the base. And again, you can use this equation. You can use B instead of A. These are just variables, whichever one makes the most sense to you. But make sure you stay consistent so you don't confuse yourself later. All right, here we go. Let's have some fun. Now, in this slide, we have a square pyramid and a triangular pyramid. Now, because these shapes are regular pyramids, they have to be regular pyramids in order for the figure to work. That's how I know, in order for the equation to work, that's how I know that over here I have a square and over here I have an equilateral triangle. Okay, because 90% of the problems we're going to deal with are going to be regular pyramids, and therefore the bases are going to be regular shapes. Just like with prisms, if you have a non-regular pyramid, they're going to tell you. If they don't tell you, you can assume it's a regular pyramid because 90% of the problems we deal with are going to be regular. Okay, we're going to do the square pyramid first, and then we'll do the triangular pyramid. So here we go. Now first off, I want the surface area of this pyramid, so I'm going to write my equation down. You guys know me, I always like to write my equation down. So I need the area of the base. I also need my lateral area, which is going to be the perimeter of the base times the slant height divided by 2, which means I need my perimeter and my slant height. Now in my figure, I have my slant height, and I need to find everything else. So, here we go. Now, as I look at my picture, I notice that I have the vertical height, the 3D height, the altitude, the slant height, and then with the apothem, I have that right triangle. So I'm going to draw that right triangle off to the side. That way it's a little easier to see and deal with. So this is 9, this is 11, this is A from my apothem. And now it's just a rounded Pythagorean theorem. So 9 squared plus A squared equals 11 squared, which means we have A squared is equal to 40. And when I take the square root of both sides, A is going to be equal to 2 root 10. Okay, go ahead and leave it as an exact number for right now. We may convert to decimals later, but for right now, leave it as an exact number. All right, so now I have my apothem, which means I'm on my base. I have this side length right here. You can see my little blue arrow. So now I'm going to draw my square, and I'm going to draw the triangle that I'm currently in. So this is 2 root 10. This is going to be half of my base and my radius. Now, because I have a square, I'm going to use the regular polygon method of solving for it. I am aware squares have their own cheat codes because they're squares and they're special, but we're going to go the long way and just kind of review how to solve for regular figures so that when you get to your pentagons and your hexagons, you know what to do. So here we go. So in order to find this angle right here, I'm going to do 360 divided by 4, the number of sides. It's going to give me 90. I don't need the full central angle. Remember, 90 is the central angle, so I'm going to divide by 2 because I only need half of it. It's going to be 45. So this angle right here is 45, which means I have a 45, 45, 90 triangle. So I'm going to use my tic-tac-toe board. 45, 45, 90, n root 2. That means that all of my legs are going to be 2 root 10 because I have a leg angle or a leg side. And my radius, it's not needed, but I'll fill it out just for the fun of it. This is going to be 2 root 10 times 2 times root 2, which is going to give me 2 square root 20, which is going to turn into 4 square root 5. All right. Now, I didn't need that piece. All I needed was B. So I know that B is now 2 root 10, which means that my full side length, I'm going to take that number and multiply by 2, which means my full side length is 4 square root 10. Now, my side length is the important part because now I get to come over here and put it into my perimeter. So I have 4 square root 10 times 4, the number of sides, and that gives me 16 square root 10. And now I have enough pieces to solve for my lateral area. So I have 16 square root 10 times 11 divided by 2. The 16 and the 2 are going to simplify, and I have 44 square root 10 as my lateral area. Now I'm going to come up here and do the area of my base. So it's a square, so I'm going to do 4 square root 10, all squared, because it's a square, and to find the area of the square, you square the base. The square is going to distribute to both, which means I have 16 times 10, which means 160 is the area of my base. Which means when I come up here, I have 44 square root 10 plus 160 as my surface area. And this would be how you would write your, well, inches squared. My bad. There you go. So this is how you would write your answer in exact numbers. So if ever the problem says leave your answer in terms of simplified radicals, fractions, this is what they're talking about. If your question wants you to simplify to the nearest tenth or whatever, at this point you should be able to go back and forth either way. But if it wants you to convert to a decimal, that means you are going to have 299.1 inches squared. So there you have on top, you have your exact number, and on the bottom, you have your rounded to the nearest tenth answer. All right, so you can kind of see that these problems, there's a process to them. You've always got to identify what you have and then what you need. Depending on the shape and depending on what you have, that's going to cause these problems to look a little bit different. That's why I really, really find it helpful to list out the things that I need, and that kind of helps you stay on track in the midst of all the busy work. All right, next problem. Now over here we have an equilateral triangle. Why don't you give it a chance, see how far you can go, and then when the video plays again, I'll take off and I will start doing the problem with you. Okay, let's see how far you got. So over here, I'm going to write my equations. I always like to write my equations to just kind of keep me grounded. Oops, that's a plus sign. So I need the area of my base and my lateral area. Lateral area is the perimeter times the slant height divided by 2. And I have a triangle down there, so the area of my base is going to be base times height divided by 2. So that means I need and I'll give myself a bit more room. perimeter of my base, slant height divided by 2. There's a lot of things that I need right now. Let's see if I'm given anything. I have 6 as a base edge, and I have 8 as my slant height. So that's going to make my lateral area nice and easy. 6 times 3 is 18. Take both of these numbers and plug it in up here. And I have 18 times 8 divided by 2. You can use a calculator, but it's always good just to kind of brush up on your math skills. So 72 is going to be my lateral area. All right, so now we got to shift gears and go to the area of the base, which means I need the base and the height of my base. So now I'm ignoring the 3D figure and only focusing on this bottom triangle. Now, of that bottom triangle, I have the base edge, that's 6. But now I'm going to come over here off to the side, and I'm going to draw my triangle. So this is 6. All the sides are 6, because I know it's an equilateral triangle. And then my height is right here. And here's where we have some fun with remembering all of our triangle rules. So number 1, because it's an equilateral triangle, I know that the altitude is going to bisect my base, which means that this piece is 3. Also, because it's an equilateral triangle, I know that this corner over here is 60, because all the angles of an equilateral triangle equal 60. Then, because I have the altitude of an equilateral triangle, I know it's also going to bisect this top angle, which means that this angle is 30. So now I have a 30, 60, 90 triangle, and all I need to do is find the height. So I'm going to go my tic-tac-toe board, and I have 30, 60, 90, n root 3, and then 2n. And really, you can choose whichever side you want, because we have 2 and we only need the third. I'm going to go with my 30 side, because that's just going to make life easy. And my height then is going to be 3 root 3. So now I'm going to come back over here. My height is 3 square root 3. And now I have all my information, so I'm going to take that and I'm going to plug it in. So I have 6 times 3 root 3 divided by 2. That's going to divide. And my answer is 9 square root 3. So now I have all my pieces. Kind of running out of room, so let me change colors and come down here. So surface area is going to be 72 plus 9 square root 3. And this, again, would be your exact answer. Feet squared. Ta-da. This is going to be your exact answer, but if the problem asked for things in terms of decimals, rounding to the nearest tenth, you can go ahead and do that, in which case it would be 87 square root 6 feet squared. This would be if you were rounding to the nearest tenth. All right, how far did you get? Now, don't get concerned if these problems get confusing. Pyramids are going to be probably one of the most puzzly problems that we deal with all section. Because with lateral area and surface area, there's just a lot of stuff to go through. But if you can stay oriented in the problem and you can remember your trig rules, special right triangle rules, and Pythagorean theorem, then you're going to be fine. And that's it. That's the end of our lesson. Let me know if you have any questions, and I'll see you next time.